Hello, this is a demo for the Mongo database in Python. Firstly, we import the Python Mongo package. My database is contracted in the cloud, and I use the Mongo signing function to connect with my database in cloud. We can list the Mongo database names. The database names are simple, admin, and local. Then let's turn to the simple database. We can list the collections in the database as follows. Mongo database stores information as collections. Each piece of information is a document. We can see that in the database sample, there are six collections. The six collections are movies, comments, embedded movies, users, theaters, and sessions. Now let's see the create operations. We can create a new collection named myCollect. Then we use the insert1 function to insert a new document in the collection. Okay, let's see the results. The insert document is here, and we can see that it is successfully inserted, and there is an ID. The ID is automatically generated for the document when we insert it into the collection. Okay, let's see the collection names. The collection names, and we can see that myCollect was created successfully. And we can use the find1 function to show the first document of this collection. The first document of this collection is the one we just inserted. And the ID is generated ID, and my name and my age. Besides, we can insert multiple documents instead of only insert one. The insert documents are here, and we use the insert many function. Then we can use the find function to print all the documents in the collection one by one. And we can see that there are the documents in the collection. We can see that Mongo database is very flexible, and no specific document structure is required. The first document has an ID, a name, and an age. The second document only has ID and name, but the last document has ID, name, and gender. They are different, but that's alright for the Mongo database, because Mongo database is flexible and there is no specific document structure. Then we can do some queries. For example, we can do some selections. For example, if we don't want the name, we can set the name to 0 in the find function. And we can see the results that there is no name, and only the ID, age, and gender. Next, we can do some queries. For example, we can search for the documents with age equal to 18. And we use the find function, and the results are as follows. We can find this document with the age equal to 18. We can also search for the name. The first letter of name is greater than M. And there are the results. The first letter of the name greater than M. In addition, we can use regular expression in queries. For example, there is an regular expression. This will return to the name that begins with Z, and that's the result. Then there is the sort operation. we can use the sort function to sort the documents by name. And let's see the results. The documents are sorted by name. Okay, that's the whole collections. And we can use the delete one function to delete one document that name equal to Chen. And after delete, that's the results. Also, we can delete the whole collection. We use the drop function to delete the whole collection. And after the drop, we can see that there is no collections. There is only 6 collections left. It was deleted successfully. Now let's see the second part of this demo. The sample database includes movies collection and users collection, and the comments of the users on these movies. Which movie has the best comments? I will try to find it. First, we use the count documents function, and we can see that there are 21,000 documents in the movies collection. And also we can see that there is 41 documents in the comments collection. Then let's see the first document of the comments collection. We can see the comments has ID, name, and email, and movie ID, and text, date. The sentimental store will be discussed in the next step. Text is the comment of a person on a movie in the collections. It is positive or negative, we don't know, but we can use the text blob package. Text blob can compute the sentiment store of the text. We use the text blob and compute the sentiment store, and the text blob will return to a number between -1 and 1. If the return value is below 0, that means the comment text is negative. If it is equal to 0, that means that the comment is neutral. And if the sentimental store is above 0, and that means the comment is positive. We can compute the sentiment store of all the documents in the collection. And then we can use the update 1 to update the results in the comment collection. It needs a long time, so there is no more demo for it. Then we will get the sentimental store of every comments, and then we can search for the best commented movie. We can find the movie that it has the highest average score. Firstly, we can construct a MongoDB pipeline. This pipeline is we group the documents by the movie ID, and then we will compute the average sentimental score for average sentimental score. Next, we will sort the collection by the average sentimental score, and we will select the number 1 document. Then we can see that the best movie is this, and we find it successfully. Then let's see the next. Maybe one movie is not enough. Let's find the titles of top N movies. We change the limit in the pipeline to 10 and show the titles of these top movies. Another thing to tell about is that some documents of movie may not have titles, so we need to check before we output. Then we can add these titles, and that's the top movies. That's the titles of top movies. Okay, that's all. Thank you.